we were to go a dilation in which the image is smaller than the original figure. Okay, so that's when you have a scale factor less than 1. If we were to go from here to here, we would be doing a reduction. Put the rulers down. Thank you. It's like so distracting to me. I have a little bit of an issue with paying attention to, and so when I see this, it's like, yeah, no. All right. Enlargement, a dilation in which the image is larger than the original figure and the scale factor is greater than 1. So, do this little warm-up for a second. This is stuff you should remember from the past. See if you remember. Do you remember how to do that? Sort of? If not, this is a reminder, okay? All right, so first thing we have to do is decide whether the dilation is a reduction or an enlargement. So did it get smaller or did it get bigger? And how do we even know?
Got bigger.
How do you know?
You don't know.
Oh, here's the center. So look for the letters that don't have the prime. They're right here, R, S, T, U. And it went to R prime, S prime, T prime, U prime. That means it got bigger.
So when the
Okay.
primes are on the outside, it means
Yeah,
it's bigger.
no prime is the original. So you look for like R and it goes to R prime. Something like that. Does that make sense to you, what I'm saying? Let me move it up a little. So it's an enlargement for this one. So here, the new points are here, aren't they? And these were the original. So what happened? Did it get bigger or smaller?
Smaller.
Smaller. So this is a reduction. These are the original right here. And these are the image. Okay. Ready?
Yeah, go ahead.
Okay, turn it over. Find the scale factor of the dilation. All right. So what you do is you do, if it goes from bigger to smaller, which it did here, right? It goes from, this was a reduction. So I'm going to make a note to myself that this got smaller. It's a reduction. When that happens, the scale factor has to be less than 1. So you have to take the image and divide it by the original. So you're looking at how far from point C. That's what the measurement is that you're going to use. How far from point C? So, how far is P prime from point C? How far is that? 7 divided by my original P. How far is that from point C? 21. So this is going to give me the scale factor. And if I reduce that, what is it? 1/3. So that's the scale factor. It has to be less than 1 if it got smaller. So check that. If it went from bigger to smaller, this better be less than 1. Okay? All right, let's do this next one. This got bigger, so this is an enlargement. That means my scale factor is going to have to be bigger than 1. So again, I'm going to do the image divided by the original. How far from C? That's what you're looking for. So how far is one of the image points from C? How far is that? 12, that's the only one I know, divided by the original, which is 3. So what's my scale factor? 4. Is that bigger than 1? Yes, it has to be bigger than 1 if it got bigger. Yeah? You with me so far?
Yeah.
Okay. Triangle STU, okay, the image is the image of triangle, or S prime, T prime, U prime is the image of triangle STU after a reduction. Find the value of x. Okay, this is something I want you to remember. And we didn't really talk about this, but it was just thrown in here, so I'm like going to remind you of it. Actually, I wrote it right here. The ratio of the dilation is the same as the ratio of the corresponding sides of the figures. It's just like the ratio of the perimeter is the same as the ratio of the corresponding sides. Also, the ratio of the dilation is the same as the ratio of the corresponding sides. So let's just see how that works. Scale factor of the dilation is equal to the ratio of the corresponding sides of the figures. So what I want you to do is I want you to look at this and say, okay, 35 is to x, right? Yes? Can you see that? So I'm going to set up that ratio. 35 is equal to x. And let's look at the ratio of the dilation. Okay? So where's C? C is down here, right? Can you see that? How far is the original from C? If I'm looking at point U, how far is that? 40 over the image. How far is that from C? U prime. 24. So what I did was I made a ratio of corresponding sides, including x, because that's what I need. I'm going to compare it to the dilation ratio, which remember is always the image over the original. Oh, I wrote it wrong. Did I write it wrong? Image over the original. Let's write that right. Let's change this. The image over the original. The image is 24 over 40. Sorry, I wrote it wrong. That's image over the original. Now let's cross multiply. See what happens. 35 times 40 equals 24x. What's 35 times 40? I'm sorry, what? I can't hear you. 1400 equals 24x. Divide by 24. What? All right. How do you tell this from the scale factor whether a dilation is a reduction or an enlargement? What did I say? If it's less than what? Number. What number? If the scale factor is less than what number? 1. Okay. If the scale factor is less than 1, it's a reduction. If the scale factor is greater than 1, it's an enlargement. Okay, so I think this was really a good kind of learning thing here. If you're going to set it up as image over the original, then make sure you set up the other part as image over original when you're looking for the x. Got it? All right.